Okay, so we've done all the operations with polynomials. We've classified polynomials. We've added them. We've subtracted them. We've multiplied a bunch of different ways. Multiply by a monomial, multiply by a binomial, multiply by trinomials, and different methods of those. The last operation is obviously division. So we're going to run through polynomial division here. In Algebra 1, we only do kind of the most basic forms of polynomial division. There are longer ones, just like when you're dividing numbers. There's long division for numbers. There's long division for polynomials too, and a couple other different methods that are used in Algebra 2. But in Algebra 1, we just stick with kind of the basic polynomial divisions. And the first one being, so polynomial division is the reverse of a multiplication. The first type that we do is just called simple division. So simple division is going to be a polynomial divided by a monomial. So multiple terms divided by one term. A polynomial divided by a monomial. Okay, so our denominator, again, we don't really use the division symbol in algebra. We just use the fraction bar. So on the denominator, you're going to have a monomial. Either, it's just going to be a number with a variable. All right, in simple division, okay, very similar to how we were doing kind of the simple multiplication, multiplying by a monomial, where it was just the distributive property plus exponent properties. It's the same thing with simple division when we're dividing by a monomial. We're just going to be using exponent properties again, except this time we'll be using exponent properties with the quotient rules rather than the multiplication and the product rules. All right, in simple division, we are going to divide each term of the polynomial, so each term in the numerator. So each term of the polynomial, that's going to be on top, by the monomial, that's going to be in the bottom of the fraction. Okay, so again, we're going to have multiple terms on top and then one term on the bottom, using exponent properties that we talked about in the last unit. So divide each term of the polynomial, which is going to be in the top, by the monomial on the bottom, using exponent properties to simplify. All right, and what's the exponent property? Again, you didn't need to know these by name, but the rule for this one is you're going to divide the numbers and then subtract the exponents. Divide the numbers, subtract the exponents. And again, it's basically the exact opposite of what we were doing when we were multiplying by a monomial and multiplying. We would multiply the numbers, add the exponents. So this is the exact opposite of that. All right, so let's look at an example, and then we'll get into the second type of division, and that's it as far as dividing polynomials goes for us. Okay, so I got this problem here. 9x to the third plus 12x squared plus 3x minus 18 divided by 3x. Okay, again, fractions are divisions. So we're going to divide each term of the polynomial on top by the monomial on the bottom, and then use exponent properties to simplify. Okay, what this means is we're going to divide each term on top by the 3x that's on the bottom. And remember, it's not just 3x. Anytime there's not anytime there's not an exponent on the variable, it's 1. So if it helps, I'm going to add 3x to the first power. Same thing on top, this x to the first. Okay, you don't have to do that, but if it helps. So what we're going to do, and I'm going to show all the steps, and if you could skip these steps, that's fine. I'm going to write them all out here for the notes. Okay. We are going to take each term on the top, and there's 4 of them. Okay, each term separated by an addition or subtraction. We're going to take each term on the top and separately divide it by the denominator. Okay, and separately divide it by 3x. So you're going to take the first term, which is 9x to the third, and we're going to divide that by 3x. Then we're going to take the second term, which is positive 12x squared, and we're going to divide that by 3x. And the same thing down the list. Each term is getting divided by, on its own, the denominator of 3x. Okay. So same thing with the 3x over 3x minus 18 over 3x. And then from here, it's just using the exponent properties. Divide the numbers, subtract the exponents. Okay. They all have an x exponent, x to the first power. Okay, so if it helps, you can include those. And just run through the list. There's 4 terms, so you're just going to do this 4 times. 9x to the third power divided by 3x to the first power. Divide the numbers. 9 divided by 3 is 3. Subtract the exponents. 3 minus 1 is 2, so 3x squared. Plus 12x squared over 3x. 12 divided by 3 is 4. Subtract the exponents. 2 minus 1 is 1. Okay, so you could put to the first power, you could leave it. The third term is 3x over 3x. Anything divided by itself is always 1. Okay. 3 divided by 3 is 1. Subtract the exponents, that would give you x to the 0, which is also 1. It would be 1 times 1. So this is just 1. And then minus, divide the numbers, subtract the exponents. Okay, well, divide the numbers. 18 divided by 3 is 6. Subtract the exponents, but there's no x on top. So if it helps, you could do x to the 0 power. 0 minus 1 is negative 1. But if you remember from the exponent properties unit, we don't want to have negative exponents in our final answers. So our final answer for this, everything is good except for that very last term. The very last term, we're going to have to get rid of the negative 1 exponent. So we will write that as 6 over x. Okay. Remember, to get rid of a negative exponent, if it's in the top, you just move it to the bottom of a fraction and make it positive. The 6 stays where it is because it's 6's to the first power. And that is our final answer. Now, one thing to note on this is we did a polynomial divided by a monomial. Okay, or monomial is a polynomial. So polynomial division, your answer isn't always a polynomial. Okay, so this answer isn't a polynomial because of the variable in the denominator. Okay, which is one of the rules of not it being a polynomial. But it's still the same process. It is still polynomial division, even though your answer is not necessarily a polynomial. It's the same thing if you're dividing, 2 whole numbers. If you divide 2 whole numbers, your answer isn't necessarily going to be a whole number. Okay, let's look at one more simple division. Okay, if you want to pause it and try this problem, go for it. We got 5a to the third b to the second minus 15a squared b to the fourth plus 10a to the fourth b to the fifth. That's our trinomial on top. And on the denominator, our monomial, 5a squared b. And again, if it helps, anything without an exponent, you could go ahead and put a 1 on. All right, so we're going to divide all 3 terms on top by 5a squared b to the first on the bottom. So what we're going to do is we're going to go to each term individually. Okay, now I'm not going to write this out the full way this time, but we're going to take each individual term on top and we're going to divide it by the denominator. Okay, so we're going to divide each number by 5. We're going to take away 2a exponents, and we're going to take away 1b exponent from each. All right, so this first one, the first term divided by the denominator, the 5a squared b to the first. 5 divided by 5 is 1. Take away 2a's from the top, or subtract the exponents. 3 minus 2 is 1. And take away 1b, or subtract the exponents. B to the second over b to the first. Take away 1b is just b to the first. So that's the first term divided by the denominator. Now we'll do the same thing with the second term. The second term divided by the denominator. Divide the number by 5. Okay, so we got negative 15 divided by 5 is negative 3. Take away the a's, 2a's. So there's 2a's on top, 2a's on the bottom. Those would just go away. I don't want to cross it out though. So there'd be no a's. And then you have 4 b's on top. There's 1 on the bottom. Take away 1 gives you b to the third. And then same thing on the last term. The third term divided by the denominator. So everything on top is getting divided by the single term on the denominator. So divide the numbers. 10 divided by 5 is 2. Take away 2a exponents, leaving 2 behind. And take away 1b exponent, which leaves 4 behind. And that's it for simple polynomial division. So hopefully that seems easy. Again, it's just exponent properties. All we are separating the problem, all the terms on top divided by the one term on the bottom. And then just exponent properties from there. There is one more type of polynomial division, and it's actually a lot of times even easier than that. So let's look at this last one, and we'll be done with this. Okay, the second type of polynomial division we do is called common factor division. Common factor division there's a special setup for it. and it's a setup we normally don't see, but we will be seeing a lot more in the future. We use it for unsimplified polynomials. All right, so all unsimplified means is they're not in standard form. So they're either, not fully distributed or they're not fully multiplied out. So there might be, a FOIL that you could see, or there might be something out in front of parentheses that you would want to distribute. Okay, but we're not going to distribute them. So these are in a couple units we're going to be calling it factored form, but for right now we'll just call them unsimplified. Okay, so they're not kind of our standard form polynomials. What we're looking for in common factor division is a common factor. Okay, hence the name. We're looking for the top and the bottom of our fraction to share a common factor. Okay, so the top and the bottom share a common factor. And what do we do with that common factor? Well, we're going to cancel it out. So if the top and bottom share a common factor, we cancel that common factor out. And again, the reason we can do that is because if there's something that matches on top and matches on the bottom, anything divided by itself is 1, and we can cancel that out because of the multiplicative identity. So everything kind of comes back to those number properties we did at the very beginning of the year. Okay. Where those number properties are really why all this other stuff works. Okay, so let's look at some examples. Hopefully you'll find that this is very easy. It's easy to spot and it's easy to do. All right, so this example we have here, we got 2x squared times 3x minus 5. That's what we mean by unsimplified. Okay. Normally we'd see that when this just screams distributive property. So we want to distribute that. But again, these are for unsimplified polynomials, so unsimplified means that distribution is not going to happen. And on the denominator we have a 2x squared. Okay. Well, do you notice anything that's the exact same on the top and the exact same on the bottom? Hopefully you do. The 2x squared. There's a 2x squared on top. There's a 2x squared on the bottom. 2x squared divided by 2x squared is 1. So we could cancel those out. So what's left is just 3x minus 5. And that is it. Okay, that counts as a division. Okay, anytime there's a fraction, it counts as a division, and anytime we're simplifying that fraction, that counts as a division. So that was a polynomial division of two common factors on top and on the bottom. Now, one thing to note is that it has to be an unsimplified form. It has to be that multiplication of two things on top. So on top here, we had a 2x squared, a monomial, times 3x minus 5, a binomial. So this is the product of two polynomials. So that is not the same example as this. So if it was 2x squared plus 3x minus 5 over 2x squared, these are not the same problem. Okay. So those are two very different problems. This denominator one, or this bottom one, when it's, there's not a distribution to be done, this is just simple division. Okay. So you would have to do that first method. It's a full polynomial, a simplified polynomial on top, divided by a monomial. Okay, the 2x squared and the 2x squared, these cannot cancel out. So never do that. Okay. They only cancel out on top because it was a multiplication. The top of this fraction is not a multiplication, it's an addition. So if you want to you could still do this division, you're just going to have to use simple division, which is just dividing each term on top by the term on the bottom. Okay, and we did that in the first section. And we can do it again here. This one, there's actually not a whole lot to simplify. The only thing we really can simplify, let's see, is we got 2x squared over 2x squared, which is just 1. In the second term, we got 3 over 2. That doesn't simplify at all. 1x on top, 2 on the bottom, so it's going to be 3 over 2x. And the last term doesn't simplify at all, so it's just going to stay 5 over 2x squared. So that's the difference between the simple division and the common factor division. Common factor division is only for unsimplified, things that aren't in standard form. Okay, and then just one last example of common factor division. So on top here we have 4 binomials multiplied together. On the bottom of this fraction we have 2 binomials multiplied together. Okay, again, this is unsimplified. Hopefully at this point, after doing FOIL for a little bit, that these binomials multiplied together are kind of, screaming at you to FOIL. Again, we need them unsimplified to use common factor division. Okay. Well, common factor division just says if there's anything that matches identically on top and bottom, we can cancel those out. Okay. So you just look at are there any common factors on top and bottom? Well, on top, I have an x minus 1, and on the bottom, there's an x minus 1. So we cross those out. There's no x plus 4. The next common factor I have is I have 2x plus 1 and 2x plus 1. And then there's no other common factors. So our answer to this one is just x plus 4 times x plus 5. Now our final answer, and again, it kind of depends on what the problem's asking. That's the right answer. That's simplified. We could go a little further on this because now what we have is we have a binomial times a binomial. So if you want to write it in simplified form, you could go ahead and FOIL this. First, outside, inside, last. Okay, so first, outside is x and 5, 5x. Quick review of FOIL. Inside, 4 times x is 4x. And then last, 4 times 5 is 20. Okay. So this is a problem that started in unsimplified form. We did the common factor division. And then we ended up with two binomials. Two binomials we were able to FOIL. And now we're left with a polynomial that is in standard form. And would be the final complete answer to that division. Okay. Now again, it depends on how the problem's set up, but we know how to manipulate polynomials now. So going in between these forms, should be kind of instinctual at this point. Okay, but that's the last polynomial operation that we had to do, which was division. Okay, again, we kind of keep it easy in Algebra 1. Common factor division, anything that matches exactly on top and exactly on the bottom, you can just cross out. Again, be very careful that you're not doing that with the simple divisions though. Okay, so like this middle example we did was not a common factor division. It was a simple division, and in the simple division all we're doing is dividing each term on top, each term of the polynomial by the monomial, and then using your exponent properties to simplify. Okay. So if there's 4 terms on top, you're going to be doing 4 divisions. And that's polynomial division. That's the last operation that we're going to be doing with polynomials. And we'll be dealing with all these operations again in the future. So make sure you know them. Division, multiplication, addition, subtraction. You got to know all of them.